The amazing thing about separation of variables is that now we can actually solve the logistic equation that we talked about before. So previously on Peyam Battlestar Galactica, we talked about the logistic equation, so logistic ODE, which gave us a better description of the population of bacteria. So models, population of bacteria. In fact, the problem we tried to study was y prime equals 3y times 1 minus y over 20. And what we were able to do, we were able to describe it qualitatively, and we got a curve that's similar to this. Namely, we had our equilibrium solution, y equals 20 and y equals 0. And we said that, well, at least qualitatively in between, the solution looks something like that, where it goes sort of from 0 to 20. And now we really have all the tools that we need to solve this. So let's roll up our sleeves and do it. So let's solve modulo technical difficulties. Let's solve dy over dt equals 3y times 1 minus y over 20. And concretely, let's suppose that initially there are 10 bacteria or tens of thousands. Now, the process that I'll explain, it seems very complicated because it is, but the good news is it's always the same procedure. So it looks scary the first time you see it, but the more you do it, the more you'll see it's always the same thing. Okay. Well, just like before, separate variables. So put the dy on one side, dt on the other side. So dy equals 3y times 1 minus y over 20 dt. And then let's divide by all those y terms. So the whole thing, dy over y times 1 minus y over 20 equals 3 dt. You may wonder, oh, what about that 3? You can really put it wherever you want. You can put it with the y's or with the t's, but this will make the next step a little bit easier. Okay, now there is this pesky 20. As you'll see, it'll make it easier to put it on the common denominator. So dy over y times 20 minus y over 20 equals 3 dt. And of course, we have all the y's on one side, all the t's on the other side. So as usual, let's integrate. And what we end up getting is the following. Integral, again, flip the denominator, so 20 over y times 20 minus y dy equals 3t plus c. Now, the right-hand side is already evaluated. Now we need to evaluate the left-hand side. And, the left-hand side is a fraction. I wonder what integral technique we can use to evaluate that fraction. So indeed, you may have guessed it. We have to use partial fractions. So partially fractions, but a whole lot of fun. And in fact, if you do it that there's this 20 here and this 20 here, it turns out the partial fraction is not too bad, because 20 over y times 20 minus y turns out It's just 1 over y times 1 over 20 minus y. And you may wonder, why is that true? No pun intended. So 20 over y times 20 minus y, you split it up as a over y plus b 20 over y, 20 minus y. Just as is usual in partial fractions. And then you get a times 20 minus y plus by over the whole thing. So then you split it up. So it's 20a minus I plus by over the denominator. And that becomes, if you want, 28 plus b minus ay over this. And we know this is 20 over the same denominator, but it's 20 plus 0y. So now all we need to do is to compare. So 20a equals 20, and then b minus a equals 0, which means that a equals 1 and b equals a equals 1. And that gives us precisely the identity above, because it says that 20 over y times 20 minus y is 1 over y plus 1 over 20 minus y. And this will allow us to evaluate our integral. Because Back to the Future, where were we so far? Integral of 20 over 20, so over y times 20 minus y, dy equals 3t plus c. But now we partially fractated this. So that was 1 over y plus 1 over 20 minus y, dy equals 3t plus c. Now, what is integral of 1 over y? Well, that's where our friend ln degeneres comes in. So ln of absolute value of y. And for this 20 minus y, you have to be very careful because there is this minus sign. So it turns out an antiderivative is not ln of 20 minus y, but minus ln of 20 minus y. And why? There's two ways of seeing it. The easiest way is to do a u sub. You can do u equals 20 minus y, and then there's a minus in the du. Or simply by using the chain rule, if you differentiate ln of 20 minus y, you get 1 over 20 minus y, but also a minus sign here, an extra minus. Good. And then we're left with this and 3t plus c. Claro que sí. And then remember the rules of ln. So that's the same as ln of y over 20 minus y equals 3t plus c. And now we can exponentiate y over 20 minus y is e to the 3t plus c. And then to remove the absolute value, you do plus minus. So plus minus e to the c, e to the 3t. And just as before, so plus minus e to the c is an arbitrary constant. So you replace it with c, and you get y over 20 minus y is c e to the 3t. And here, c is non-zero because the initial condition, basically. Good. And it turns out what this gives you is an equation that you can solve for y. So solve for y. And here, let's cross multiply. So y equals ce to the 3t times 20 minus y. So y is 20c e to the 3t minus cy e to the 3t. Let's put all the y's on one side. Y plus cy e to the 3t is 20c e to the 3t. And then we get y times 1 plus ce to the 3t equals 20c e to the 3t. And then we get y is 20c e to the 3t over 1 plus c e to the 3t. Now, there's a huge mistake that people do at this step, because one way of arguing is to say, well, 20c is arbitrary, so we can just replace it by c, and to get c e to the 3t plus over 1 plus c e to the 3t. But this is unfortunately wrong. And the reason is there is already a c in the denominator. So if you replace 20c by c, you have to divide the bottom by 20 as well. So it's kind of the relative values that are important here. So in other words, if you see those c twice, don't relabel them. And last but not least, we can actually find the value of c using the initial condition. So let's do y of 0 equals 10, I believe. And then you just get 10 equals 20c e to the 0 of 1 plus c e to the 0. And you get 10 is 20c over 1 plus c. And then you can solve for this. So you can cross multiply. 10 times 1 plus c equals 20c. And then you get 10 plus 10c equals 20c. And essentially, I believe 10c is 10. And so c is 1. And therefore, we are done, because we finally get our answer. Y, in this case, is 20 e to the 3t over 1 plus e to the 3t. The box failed. Let me try again. Okay, nice. And I want to emphasize, if you leave it in this form, no, you get full credit. But if you want to simplify this sort of a bit further, you can factor out e to the 3t from the numerator and denominator to get e to the minus 3t plus 1, and then e to the 3t. This cancels out, and you get 20 over e to the minus 3t plus 1. And this will be useful because we can then calculate the limit. So note, so as t goes to infinity, y goes to 20 over 0 plus 1 is 20, which confirms our suspicions that we had before, because remember, what was the idea? Well, we had this population of bacteria that starts at 10, but because of limiting resources, it will actually stop at 20. So if you actually plot the solution now, we get that, well, it goes from 0 to 10 and then to 20. Which is really cool because before we did a qualitative study of that, but now we actually have an explicit solution. And why is that? Because of the magic of separation of variables.